Okay, so we're trying to introduce ourselves to integration. We've already kind of talked about how integration is going to be taking the antiderivative. We talked about that when we introduced the antiderivative. We're working with the fact that now taking the integral is also finding the area under the curve. And we've been dealing with a method for finding the area under the curve, which I call RAM, which I believe stands for rectangular approximation method. Okay. And we talked about using the program. And we'll talk today about how we could use that program you have in your calculator. We'll have to get it for Rebecca somehow. Welcome back. But we're also going to talk about how we can use the rectangular approximation method by hand. Okay? So I've got a couple more example problems that I want to do. And then if there are journal questions, we can do the journal questions. But we're going to start with page 276. Number 24, if somebody would read that for us, please. All right, quite the mouthful there. Let's start by redrawing the picture from the book. Okay, so if we have the function y equals radical x, that's also going to be x is equal to y squared, right? If I square both sides, which tells you that the shape that I'm looking at is a what? It's a parabola, but it's going to be a sideways parabola. Okay, so it's going to look something like this. So this is going to be y equals radical x. And I've got my tick marks. Okay, on my axis, I'm going from 0 out to 5. And the problem says, number 1, to partition this interval into 5 subintervals of equal length. So that means that each interval is going to have a length of 1, which is eventually going to be the height of our, bless you, cylinder. Okay. And it says that we're supposed to use the subinterval's left endpoints when we construct our cylinders. Okay, so first of all, remember that this whole thing has been rotated so that what I really have is kind of like a funky ice cream cone. Okay, it's a three-dimensional solid thing. Okay. And so if I'm looking at the intervals, say, from 2 to 3, I'm going to take the value at the left end, and that's going to give me my cylinder. My cylinder from 3 to 4, I take the value at 3, and that's what I use to make my cylinder. This kind of needs to go out more. And for my interval from 4 to 5, I use the value at 4 to make my cylinder, because I'm slicing it. The interval from 1 to 2 isn't too bad. I'm going to take the value at 1 But what's going to happen from 0 to 1? Well, let's draw the cylinder first from 0 to 1. Because you're right, there's going to be a whole heck of a lot of unaccounted for space. But if I'm looking at 0 to 1, and I have to take the value at the left end, what is that x value? What's the y value at that left end? 0. Okay, so my cylinder from 0 to 1 actually doesn't exist. It's a line. It has no volume. So as Sarah said, yeah, there's going to be a whole lot of unaccounted for space there. Okay, so remember that each of these is a cylinder. Each of these cylinders is going to have a radius. Actually, I take that back. I'm going to make the radius go this way. Each of these cylinders has a radius, and each of these cylinders has a height that's equal to 1. Now, we could solve this 2 different ways. You know what the volume of a cylinder is, right? What's the volume of a cylinder? Pi r squared h. Okay. Yes. The same thing will work if you take the derivative of the area of a circle. You'll get its circumference. Oh, okay. Yes, for a circle. Because you can do it for a sphere. If you take the derivative of the volume of a sphere, you'll get the surface area. Cool things you figure out in calculus. I remember being excited when I figured it out myself. Okay. Although I think it only works for circular things. It doesn't work nearly as nicely for cubes. All right, so this is an easy formula. There's only 5 cylinders. Really, there's only 4. So we could figure out this volume by hand, and we will at the end. Okay, right? Because it would only be 4 calculations. We could figure out what the radii were. We could make it work. Okay, but we could also use RAM. Okay, and if we're going to use RAM, though, that program that you have in your calculator, remember that we need a function that we're going to plot. Okay, whether we actually plot that function or not. So what are we trying to find again? No. What's the problem asking us to find? We're trying to find the volume of the nose cone, which we just established was pi r squared h. Okay. So if V is what I'm trying to find, then V is probably what I want to plot. Okay, that's probably what I want y1 to be equal to when I put it into my calculator. So we're going to have to somehow turn this into a function of what? X. Okay, so there's a couple things I can do. Like, for instance, what's h equal to? 1. All right, so that's going to make my life easier. If I go back to my picture here, what's r equal to? It's y, right? It's the y value that goes with whatever that x value is. Oh, hang on, we're getting there. Okay, so I can say that r is equal to y. What I really want in my formula, of course, is r squared, which is equal to y squared. And what did we figure out y squared was equal to, Maggie? X. Okay. So v of x, which is what we want y1 to be equal to in your calculator, is really going to be equal to what? pi x. Okay. So put in y equals pi x, or y1 equals pi x into your calculator, for those of you who have the program. Some of you don't. Okay. Turn around and help a friend who doesn't have that in their calculator. Okay. And then what are you going to let little a be equal to? 0. And what are you going to let b be equal to? And what's my no subint going to be equal to? 5, because they tell me I need 5 subintervals. Rebecca, stop by during lunch. Do you have a calculator like Gianni's, right? Or do you have one like Zoe's? Yeah, okay. Come by during lunch and I'll transfer the program to you. Oh, okay, Casey. Come by during lunch. We may have a minute in physics too to do it. Okay. So remember that you get 3 values that pop out. Which value, RRAM, MRAM, or LRAM, do you think you should be taking here? LRAM. Why, Maddie? Yeah, we took the left boundary when we made our cylinders. So what's the value we get for LRAM? Give me all 5 decimal things there. Okay. Because what we're going to do now, did everybody get that? Okay. What we're going to do now is go back and calculate it by hand and see if we get that. And in reality, we will get that, like out to 5 decimal places. Okay. All right. Everybody good? Everybody got what they need? Okay. So we said that we could also calculate this by hand. Okay, you'll still use your calculator, but we're not going to use an actual program. So when we do that, we're going to say that the volume is going to be the volume of that interval from 0 to 1, plus the volume from 1 to 2, plus the volume from 2 to 3, plus the volume from 3 to 4, plus the volume from 4 to 5. Okay. And what's our formula for the volume of a cylinder again? Okay. Pi r squared h. We know that the h is equal to 1. And what did we say r squared was equal to? X. Okay. So just for when I calculate this, it's going to be pi x. But this is going to be the x value at the left edge of the interval. So when I take the interval from 0 to 1, it's going to be pi times what? 0. The interval from 1 to 2, it's going to be pi times 1. The interval from 2 to 3, pi times. The interval from 3 to 4, pi times. And the interval from 4 to 5, pi times 4. So that gives us 3, 7, 9, 10 pi. And if you figure out what it is as a decimal, what do you get? which, surprise, surprise, is exactly what we got with RAM. It will not always work out this closely. Okay. All right. Everybody got what they need? So you may ask yourself, if I have this handy dandy computer program, why would I ever bother figuring it out by hand? Yes, zombie apocalypse is almost always a good answer. But in addition, sometimes you are given the information about the y values in a table, and there's no easy way to figure out what the function is. So let's look, for instance, at page 276, number 28. If somebody would read that for us, please, through part A. Okay, so I'm just going to quickly copy the table here so that I can point at things. Okay, you don't necessarily need to copy the table. You have yours in your book, but I can't point at it when it's in the book. Okay, so is this a straight line? How do you know it's not a straight line? Yeah. Okay, so the delta in leakage, the slope as it were, between the intervals is not the same. If it was a straight line, the difference from hour to hour would be the same. So there may very well be a function that fits this, but I don't know what it is, and it's really not worth my time to figure out what it is. And the math involved in figuring out what it is probably beyond what we are capable of in this class right now. Okay. So, part A says give an upper and a lower estimate for the total quantity of oil that has escaped after 5 hours. So, let's start by looking at the upper limit. So, note that over the course of an interval, as we go from 0 to 1, somehow the amount of oil that's leaking is changing from 50 to 70 gallons per hour. Okay? It's not like I just turn the faucet on harder when 1 hour starts and now I'm losing 70. Okay? It's more of a gradual thing. So in this case, upper limit is synonymous with worst case scenario. Huh? Well, it'd be awfully nice if I could say, I bet you for all of the interval from 0 to 1, it was really closer to 50. But the worst case scenario would be that from 0 to 1, it was really closer to 70. So it's kind of the difference between taking LRAM and RRAM. And in this case, because this is increasing, the upper limit, or the worst case scenario, is going to be actually RRAM. Because the values are always going to be bigger on the right side of the interval. Okay. So after 1 hour, if I'm taking my RAM, so that I'm using the value that the leakage has on the right-hand side of the interval, how much oil have I lost after 1 hour? No, because I'm going from 0 to 1. So I want to know, it's kind of like, here I'm starting my clock. At the end of 1 hour, 70. Okay. How about from 1 to 2 hours? 97, because again, I'm going to take my value at the right-hand side of the interval. From 2 to 3 hours. These are all gallons. 136, good. From 3 to 4 hours. Yes. And from 4 to 5 hours. So these values, I don't want to use a minus sign, but these values are the amount that I'm losing every hour. If I assume that the rate for that hour is the worst that it could be, the highest value. So if we add all those up, the amount of oil we lost each hour, that'll give us an upper limit. So what do you get if you add all those up? Yeah, 758. Okay. So if taking our RAM, if taking the values on the upper values on the right side of the interval gives me an upper limit, or the worst case scenario, what do you think I do to get the lower limit, or the best case scenario? Yeah. So now I'm going to take the left side of the interval and use that as my value. So again, from 0 to 1 hour, I'm going to use the value here at the beginning of the interval, which is going to be that 50. Okay. How about from 1 to 2 hours? What am I going to lose in that second hour? 70. How about my third hour? 97. 3 to 4. And 4 to 5. So what do you get when you add it all together? Is she right? All right. So somebody read part B for us. Okay, so you do that. Anybody have an answer they want to pop up on the board? Sarah, go ahead. Yeah, go up and write it. I myself am tethered near here, but I'll move out of the way. You can write both up there if you have them. Is Sarah right? Okay, I agree as well. So, how about part C? What does part C ask us? See if we can finish this up real quick. Okay, so worst case, again, is our upper limit. So what are we going to do here? So what do you think? Okay, so we're going to take the total amount in gallons minus the number that we figured out for the number of gallons that was lost in those first 8 hours. So again, if we're talking about the worst case and the upper limit, that was 2363 gallons from the last slide. And what are we going to get when we do that math? Well, I want this math first. Okay, the 22,637 gallons. Okay, so if I've got 22,637 gallons, and I know that every hour I'm going to leak 720 gallons, we can do a little dimensional analysis, or however you want to call it. And when we do that math, that's where we get the 31.44 hours. Okay? You would do something similar for the best case scenario or the lower limit. Yes, because they say that it's 720 gallons. They have to give you a number for everything past 8 hours. Okay? And so that answer, if you care, is 32.37 hours, but you can redo the math. You can do that math on your own, okay? Because the bell's going to ring. Tomorrow we start 6.2, and I will answer journal questions for 6.1 if you have them tomorrow.